Okay, so let's try a numerical. So it is given that it follows the Laplace equation. Okay, and we have already derived the formulation for the Laplace equation. So this is what is the formulation. Okay, so I could label this as A. So we are supposed to use equation A to solve this problem. Now what they have given us a grid. So this is a plate and having a certain thickness. Okay, so temperature variation within the plane is same, so therefore thickness won't come into the picture, and it is a mesh of 1 by 1. So mesh of 1 by 1, it is given that mesh size is 1, so its meaning is H is 1 and K is also 1. Okay, on the left hand side they have mentioned temperature 0 degrees Celsius. On the top side they have given temperature 100 degrees Celsius. At the bottom side we have the 50 degrees Celsius temperature, and on the other side we have the 25 degrees Celsius temperature. Temperatures are always applied at the level. Okay, so here in this case the unknown temperature we are supposed to find. So at this location the temperature is T1, at this location the temperature is T2, at this location temperature is T3, and at this location temperature is T4. So you could label it anyway, whichever you like. There is no sequence to label this. Okay, now what we are going to do here in this case is we are going to set up an equation for T1, T2, T3 and T4. Now if I focus on T1, if I focus on T1 and I look after this picture, so what it says, sum of the surrounding temperature. So which are the surrounding temperature? So surrounding temperature is T2, 100 degrees Celsius, 0 degrees Celsius and T3. So these four are the surrounding temperatures of T1. So therefore I can write my T1 as 1 by 4 T2 plus 100 plus 0 plus T3. I label this as equation 1. So if you have understood equation 1, please type 1, or else you may have your question. Okay, similarly we can write equation for T2 1 by 4. So this is 25. So I use some different symbol now, cross 25 plus 100 plus T1 plus T4. So this is my equation number 2. So let help me by typing 2. If you have understood 2. Okay, so now T3 will be equal to 1 by 4 T4 plus T1 plus 0 plus 50. This is my equation number 3. Then I have fourth equation 1 by 4. So that will be 25 plus T2 plus T3 plus 50. This is my equation number 4. Okay. Now you could see this is a set of equation. Okay, it is a simultaneous equation. 4 simultaneous equation. If you could rearrange it, you will get 4 simultaneous equation. Okay, and then by solving this 4 simultaneous equation, we are going to get T1, T2, T3 and T4. But when you use some kind of direct method, as the number of equation increases, the accuracy is a big challenge. And one could also see that if I use iterative method, I need to set up an equation in some specific format. Now, if you observe carefully, 1, 2, 3, 4, it is nicely set up to use Gauss-Seidel method. Okay, so though we don't have to do anything, and it is nicely set up to use Gauss-Seidel method. The only thing is what initial assumptions I am going to make it to get this problem to solve. So in Gauss-Seidel, we have studied that we started with initial guess 0, but if you remember, that time I told you the initial value depends upon what kind of problem you are trying to solve. So here in this case I am trying to solve a temperature based problem. So it is but obvious temperature T1 and T3 will be somewhere near to 50 degrees Celsius somehow. Okay, so there is no point assuming T1 and T3 to be 0 degrees Celsius at the beginning, because it is going to take longer duration of time to actually stabilize the values of T1 and T3 during the iteration process using the Gauss-Seidel method. If we want a faster answer, our assumption should be as close as possible to the actual value. So I could see T1 and T3 could be somewhere near 50 because it is near to 0 and 100 degrees Celsius and to 50 degrees Celsius. And of course T2 and T4, I could see they are very close to maybe 33-35 degrees Celsius, okay, or maybe even 70 degrees Celsius. So depending upon your assumptions, the number of iterations is going to take, what you say is going to vary. So let's assume T1 and T3 to be 50 degrees Celsius, okay, and assume T2 and T4 to be 70 degrees Celsius. Okay, so let's try T1, T2, T3 and T4. So put T2 and T3 in this value, okay, which we have assumed. So T3 is 50 and T2 is 70, and let me know the value of T1. So it is nicely set up for Gauss-Seidel method. So in equation 1, put down the value of T2 and put down the value of T3, which we have assumed, and get the value of T1. Okay, I got the value of 55. Now in equation 2, I need T1, which recently I got as 55. I need T4, which is 70. So get me value of T2. Yeah, so everybody is getting 62.5. Great. Now T3, so T4 is 70 degrees Celsius, T1 is 55 degrees Celsius. So get me the value of T3. 43.75. So let us use latest value of T2, which is 62.5, T3 43.7.5. Get the value of T4 from equation 4. So 45.3125. Okay. So now again get the value of T1. Use the latest value of T2 and T3, which is 62.5 and 43.75. And from equation 1, get the value of T1 again. $51.5625. Get the value of T2 now using latest value from equation 2. $55.9688. It's not. अरे कुठलं बरोबर आहे? 55.4687. Okay, great. Now similarly get the T3. Now you can note down those values. So you can continue in this fashion to get all the values until it converges. So I try to write the equation. So it is 4, coefficient of T2 is 1, coefficient of T3 is 1, coefficient of T4 is 0. Now coefficient of T1 is 1, coefficient of T2 is 4, coefficient of T3 is 0, coefficient of T4 is 1. Then we have coefficient of T1 1, coefficient of T2 0, coefficient of T3 4, and coefficient of T4 1. Lastly, we have coefficient of T1 0, T2 1, T3 1, and T4 4. So already it is a diagonally dominant. So we have 100, then we have 125, then we have 50, and then we have 75. So this is what is my equations. So it is already pivoted. So I just uncheck it and solve it. What is the problem now? Initial guess is the problem. Please enter valid number. Here. So initial guess, this is I will specify. So what I will do, I will say 50 as usual, and then I have assumed this to be 70 and this to be 70. Okay, and I can hit solve. So I'm getting something different result. -5. Okay, I may have made some mistake while putting this value somewhere dot or something. Okay, so this is, you can use this to find the solution. Always 4 by 4 it can solve. Now what you can do, I can go into elliptical method, finite difference, and I can also try to test it out here. So this I can put a 0, here I can put 100. So mesh size is available 3 by 3, 4 by 4, and 5 by 5. So you can use any mesh size. This was 25 and this was 50. Okay, and I can hit solve. So after doing so many iterations, so what we observe that this is going to reach to 46.875, this is going to reach 53.125, this is going to reach 34.375, and this is going to reach 40.625. So these are the answers. So you have to keep on doing this process uh, for some time, for some duration, till the you achieve the desired accuracy, or that means you are keep getting the same result again and again. So at that moment you have to stop. Okay, so here in this case, this is what results you will be getting it. So you can note down these values, and later on you can do the further processing. Okay, you can take the screenshots of this, or you can use this tool to solve the problem. So a different varieties of problem is also given here, which you can solve with the help of this, and uh, make use of the simulator most effectively. Okay, so now we move to the, so okay, up till now if you have understood how you are going to go ahead, you can type U please. So I will move to the next topic. Okay, great. So now we are going to have some different boundary conditions. Yeah, just let me know once again whether my screen is visible. Anybody can unmute and answer.
Yes, sir.
Okay, thank you. So now we will have this type of grid. Okay, mesh size is again 1. Okay, I am taking mesh size 1 for the simplicity purpose. Okay, even mesh size is 3, it doesn't make any difference, because if the value of h and k is same, it is going to get multiplied to 0 and it is going to get cancelled. Okay, so only what we want, a mesh should be of square size. So height and width of the mesh should be height and width of the that particular uh, cell should be same. Okay, so this is the cell. So this is 1, so this is 1, so it is height and width is same, so there is no trouble. Okay, if it is different, then we have to treat it differently. Okay, so now what I do, so it's a very tough challenge, huh? Such type of problem solving using conventional heat transfer methods. Okay, but numerical method helps you to solve that. In heat transfer, you do not solve such problems because it's very complicated. Okay, but there is a way to solve it with the help of numerical method, computational fluid dynamics, and finite element methods. Okay, so this is a finite difference method what we are trying to study. So let's consider temperature at this location is 100, at this location is 50, and let's assume here temperature is 0 and 75. Okay, so this is the case given to you. Okay, and this is the insulation. Okay, it is insulated at the other end. So there will be temperature T1, T2, T3 and T4. So at this location there will be temperatures. So T3 is here, T1 is here, T2 is here. Okay. So now I ask you a question. T3, option A, smallest. Okay. Option B, near to 0 and T1. Option C, largest. Option D, okay, no heat transfer at T3. Okay, so difficult choices are there. So answer me. कौन सी को तो heat transfer? Okay, so answer this question now. So A, B, C, D. These are the options. चला सगळ्यांनी आन्सर करायचं. So there are 65 students, so I want 65 answers. Okay. So this is the correct answer. Answer D. No heat transfer at T3. So it is insulated, therefore there won't be any kind of heat transfer from T3 on this side. What is the meaning? There is no gradient. Okay, what is it meaning? There is no gradient. Remember Fourier's law of conduction. There is no gradient along this. So if you remember the Fourier's law of conduction, so at T3, what is valid is delta T, and this is my x direction, this is my y direction. So what is valid at T3 is delta T by delta x is equal to 0. There is no heat transfer along this. So at T3 delta T by delta x equal to 0. This is valid one. So I can call this as a 1. हे जर delta T by delta x equal to 0 का लिहितोय आपण T3 ला हे जर कळलं असेल तर 1 टाइप करा. There is no gradient on the right hand side. The insulation means. जर हे कळलं असेल तर 1 टाइप करा, नाही तर प्रश्न तरी विचारा. Okay. So what is the meaning? Delta T by delta x is equal to 0. Okay. According to central difference. If you remember, according to central difference, it is in x direction. Okay, you have to remember it is in x direction. Ti plus 1 j minus Ti minus 1 j divided by 2h. So this is equation number 2. आता हे 2 कळलं का central difference नी, तर 2 टाइप करायचा. This is the central difference formula. ओके, याचा अर्थ काय? Ti plus 1j is equal to Ti minus 1j. This is what is meaning. Okay, so Ti plus 1j is equal to Ti minus 1j. That is what is its meaning. So if I draw a grid again, at this location this condition is valid. So if I call this as a this location, it will you Tij, मी याला Tij जर कॉल केलं, so this value will be Ti plus 1j. So here it is virtual value on this side, but this value does not exist, and this value will be Ti minus 1j. So this value will be Ti minus 1j. So what it suggests, at this point, whenever you require this value is nothing but equal to this value. This is what is the meaning of this. Okay. So when I want to write out this value, suppose I call this value as just T1 and this value as T2. Okay. So how do I write Tij? Is equal to 1 by 4 Ti plus 1j, which does not exist. Okay, plus T1 plus Ti minus 1j plus T2. Okay, so this is the way I write it, but Ti1 plus 1 does not exist, but we know the formulation that this value is equal to this one. So I could replace 1 by 4 Ti minus 1j plus T1 plus Ti minus 1j plus T2 in this way. So this is my Tij. So this virtual value is nothing but equal to this value. This is what is the meaning of delta T by delta X equal to 0. So if you understood this concept, you can type U. नाही तर प्रश्न विचारा नसेल कळलं तर. Okay, so now what I do, I write the 4 equations for this problem which we have written. So T1 is equal to 1 by 4 T3 plus 0 plus 100 plus T2. So this is my equation 1, and T2 equal to 1 by 4 T1 plus 50. This is T1 plus 50 plus 75 plus T4, and my T3 will be equal to, on this side is equal to T1. So 1 by 4 T1 plus, okay, I need to provide temperature at this location also. So here 0 and 75. So these are the same temperature I am applying. So I have the 0. Okay, so this virtual temperature is equal to T1, 0, again T1 back, because this side temperature I have to take. So T1 again back plus T4. Okay, and T4 will be equal to, so this is the temperature, this is the virtual, which is equal to T2, 1 by 4 T2 plus T3 again back to T2 and plus 75. So this is the way I could set up this 4 equation. So if 4 equation you have understood, the what else remain is how to solve it. So what we are going to use? Gauss-Seidel method. So we are not going to waste the time to solve this by Gauss-Seidel method. If you have understood this formulation, type Y please.